Hello friends, welcome back to STM32 tutorials. I am Ajinkya and we are here to learn embedded system with STM32F103 controller. In this video, we will learn how to interface a 4x4 keypad with STM32. So why do we need this? There are reasons a 4x4 keypad matrix is very popular. It is used to enter the security code or a certain number or certain IDs. So where it is used? A 4x4 keypad matrix is used to enter the security code, to dial numbers at ATM machines, in calculators. This is how a 4x4 keypad matrix looks like. So how does it work? If you look inside a 4x4 keypad matrix, it will somewhat look like. This is a representation of 4x3 keypad matrix. A 4x4 keypad matrix has a similar circuit. We have placed voltage probes at the end of the resistor to see what happens when we press a switch. We will see working on a keypad. So we have a 4x4 keypad that is used in calculators. We have connected resistors to row connections and we also have placed voltage probes. So as you can see, there are numbers on the keypad and some math operators. When you press a key, you can observe the voltage dropping down to 0 volts. So what happens here is that when you press a certain key, the resistor end will be connected to ground terminal through the key. Here you can observe that when you press a key in a certain row, the voltage drops down to 0 volt for that particular row. So we will try it for other rows also. Here is another keypad that is used in old phones for number dialing. You can also observe here that when you press a key, the voltage drops down to 0 volt. Now let's build the circuit. Here I have already built the circuit. So I have connected a 4x4 keypad and a 7-segment display with STM32 controller. The 7-segment display is used for visualizing which key is pressed. So let's have a look at the circuit. So I'll zoom into the circuit. So I have connected a 4x4 keypad with GPIOs of port A. For rows, I have used GPIO PA0, PA1, PA2 and PA3, and for columns, I have used PA6 to PA7. The resistors are connected in series so that VCC and ground are not shorted directly. Now we will have a look at the 7-segment display connections. I'll zoom in a little bit. Here we have used a common anode 7-segment display and the common terminal is connected to VCC. We have used series resistor to limit the current flowing through the LED segments. So we have connected 7-segment display to port B from PB0 to PB6. Now let's have the look at the overall circuit. Now we will open STM32 CubeMX. The CubeMX software is required to set the functionalities of the GPIO. I have already set the GPIO functionalities. For row connections, we are going to use PA0, PA1, PA2 and PA3. For column connections, we are going to use PA6, PA7, PA8 and PA9. And for the 7-segment display, we are going to use PB0 to PB6. Now let's go to the project management tab, set the project name, set the directory, select the toolchain IDE as MDK ARM and click on generate code. Open the Keil IDE, go to the main function. Here I have already written the code. So first there is a local variable and its scope is limited to that function only. Here I have initialized the GPIOs. I have set the row connections to logic high. So one side of the key will be connected to VCC through the resistor and the second terminal will be connected to ground. Here I have set the column connections to logic 0 so that the second terminal of the key will be connected to ground. Initially we are keeping the 7-segment display off. So we have set the 7-segment display connections to logic 1. After that we have just displayed 0 to see the 7-segment display is working or not, and we have provided a small delay. In the while loop I have written 3 lines of code. First one is the key press to check which key is pressed. The second one is to display the key on the 7-segment display, and the third one is the delay. We have written a small display function for 7-segment. In the first 2 lines I have declared the local variables. In the character array I have written the hex code values for a particular character to display on the 7-segment display, such as 0, 1, 2, 3, 4 and so on. In addition to the 16 hex code, I have added one extra to turn off the display. The code is very simple. You mask the last bit and assign it to the GPIO port. Then you shift the original value by 1 and then mask it with 0x01 and then assign it to the GPIO port. The same thing is done for all the GPIO ports, except the right shift count will vary. So as you can see that we have shifted it by 1, then by 2, then by 3 and then by 4 and so on. Now let's see what's inside the key press function. So as you can see that we have defined the key press function as unsigned character key press, and no parameters are being passed to the key press function. So we have written void. The unsigned char before the key press suggests that the key press function will return character value. Now let's look into it. So as you can see that in the key array we have written the numbers from 0 to 15 in random manner. These numbers are written in a sequence that they occur on a keypad from top to bottom. We will see how the function works. The row voltage will drop down only when a key is pressed. So we are checking exactly that. When a row voltage drops down, that means a key is pressed in that row. So we will check that a row voltage is equals to logic 0 or logic 1. If a row voltage is equals to 0, we will check that which column key is pressed. If the first row voltage is not equals to 0, we will check for the second one. If the second row voltage is not equals to 0, then we will check for the third one. If the third row voltage is not equals to 0, we will check for the fourth one. Else we will return the number 17. That means turn the display off. So we have written another function check column and we have passed a parameter GPIO pin number. So we will check that if row 1 equals to 0, we will pass the same GPIO pin for that row and we will check which column key is pressed. So whatever we get from check column function, we will assign it to column variable and we will return the particular pressed key from the key array. Now let's dive into check column function. So we have defined the check column function as unsigned char check column and we have passed an unsigned char parameter which will be our GPIO pin number. After coming to check column function, I have set all the column pins to logic 1. This we must do to check which column key is making the row connection to logic 0. After making all the column pins to logic 1, we will set single column to logic 0 and we will check that the key in that particular column is making that row connected to logic 0 or not. If that key is connecting the particular row to logic 0, then we will return that column value. Else we will check for the next column. Before setting the second column to logic 0, we will make the first column set to logic 1. so there will be no confusion between which column key is making that row connected to logic 0. If the second column key is making that row connected to logic 0, then we will return column value as 2. Else, we'll check for the third column whether it is making that particular row connected to logic 0 or not. So the if statement is checking that the particular column key is making that particular row connected to logic 0 or not. At the end of the check column function, we have set all the column connections to logic 0 and we have returned the column variable. Now let's build the code. So there are 0 errors. Let's go to the simulation. Double click on controller, load the hex file and click on run. So you can see that when we press a particular key, that key is displayed on the 7-segment display. If you enjoyed the video, click on like, share and subscribe.